Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Today we want to present about our project, which is numerical methods section 3 by group 9. So the title that we choose is the second method to find the depth of submerged ball when floating in water. And this is our group member from group 9, which is Ammzar Azryl bin Amrudin, CE 210143. I am Muhammad Aizil Fikri Raslan, DE 2041, and Farhana Arisya Binti Isnadi, AE 2067. So for the introduction, I will pass to Ammzar Azryl bin Amrudin to present about it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ammzar bin Amrudin. My metric number is CE210143. Okay, so today I want to present for my part, that is introduction. Okay, so for the project background, the second method is an effective numerical approach for the resolving nonlinear equation of the form function x equal to 0 is generated using a linear interpolation process that only use fx value that are close to the root of fx equal to 0. So it only compute fx once every iteration in this node. We generalize it by substituting an appropriate k plus 1 point polynomial of interpolation for the relevant linear interpolant where k is an integer of at least 2. Okay, so for the problem solving, a company make float for ABC commode. The floating ball has a specific gravity of 0.6 and a radius of 5.5 cm. You are asked to find the depth to which the ball is submerged when floating in water. The equation that gives the depth x to which the ball is submerged underwater is given by x power of 3 minus 0.615 times 2 plus 3.993 times 10 power of negative 4. Okay, so at the right side is the example of the situation. Okay, so for the objective for this this project is to analyze the problem and provide a solution using second method, and to run the simulation of the calculation by using MATLAB.
Assalamualaikum and good day. My name is Farhana Arisya Binti Muhammad Isnadi. My metric number is AE200067. Today I will tell you about the method that we use to solve this project. The first equation is the iterative formula that is given from the Newton-Raphson method of solving a nonlinear equation of fx equals to 0. The second equation is the derivative of the function fx. Then if we substitute the equation 2 into equation 1, we got the formula of second method. The second method can also be derived from geometry as shown in the figure in the slide. Taking two initial guesses, xi minus 1 and xi, one draws a straight line between fx1 and fxi minus 1, passing through the x-axis at x1 minus 1. ABE and DCE are similar triangles. Hence, AB over AE is equals to DC over DE. So after we rearrange the equation, we got the last equation, which is shown here. So that is how we derive the formula of second method. Now I will show you the manual calculation of our project. We will use the formula that we have derived just now. So for second method, we will do a few iterations until the absolute relative approximate error is less than 5%. So for the first iteration, we got 0.06461 for manual calculation, and the absolute relative approximate error is 22.62%, which is still more than 5%. And then for the second iteration, we got 0.06241, and the absolute relative approximate error is 3.525%. And then for the third iteration, we got 0.06238, and the absolute relative approximate error is 0.0595%, which is less than 0.5%. Since the absolute relative approximate error is less than 0.5%, therefore our iteration ends at iteration 3. Finally, all of the data that we have calculated, we will tabulate it in the table. So this is our table. So that's all from me. Thank you.
Okay, thank you for Farhana Arisya for the manual calculation. So I want to proceed for the MATLAB simulation, and basically this is the coding that we use in the project, which is sims x, which is defined for variable x, and the value of f, which is x to the power of 3 minus 0.165 x to the power of 2 and plus 3.993 exponent to the power of negative 4, which is the value of f is given from the proposal, and the value of g equal to differentiate the value of f, and the value of prompts equal to enter the initial approximation, which is 0.04, and x0 equal to input from this, and the value for I is equal to 1 over 3, and the value of f0 derivative, and y, which is the value of y equal to x0 minus f0, and divide by f0 derivative, which is this formula is from Newton-Raphson formula and the error. So we get the result from the coding, which is the absolute relative error after iteration 1 equal to 0.372315, and for the iteration 2 we get 0.021704, and last for the iteration number 3, which is we get 0.00082, which is near to the value of 0, and the depth that we get, which is x, is 0.062378 meter, which is absolute the same from the manual calculation. And for the discussion, the depth between manual calculation and simulation is about the same each other, and for the manual solutions is used from previous lesson which learned in class session, and for the simulation use MATLAB simulation, and it is more faster than manual calculation and convenient to use. And for the second method, why we use the second method, it is the fastest way to get an answer and only have 3 iteration, while other method, which is Newton-Raphson method and bisection method, need to use 13 iteration. So what is the conclusion from our project? So the study's goal was met and everything proceeded according to the plan, and we can utilize the simulation tool in this project using MATLAB software. Also, we can analyze the engineering issue and offer a solution utilizing numerical methods, and the problem solving by the ABC factory is solved. And last but not least, we can gain a true understanding of fundamental theorems and numerical methods. So that's all from our group 9 for the presentation, and thank you and bye.